All right, listen up. Welcome to The Explainer. Today, we're stripping away all that theoretical fluff and getting straight down to the tactical mechanics of everyday math. Consider me your drill sergeant for this session and consider yourself officially enrolled in Math Boot Camp. Because guess what? The real world absolutely does not care if you forgot your formulas. Out there, you're going to face taxes, crazy currency exchanges, and deeply confusing sales tax. We are going to master proportions, conversions, and percentages right now so you can actually survive and thrive out in the wild. We're running this fast and we're running it hard. So square your shoulders, eyes front, and let's get into it.
Here is your training regimen. First up, welcome to Math Boot Camp. Second, direct versus inverse proportions. Third, we face multiple threats with joint proportionality. Fourth, we execute tactical unit conversion factors. And finally, surviving real-world percentages. Section 1. Welcome to Math Boot Camp. Proportions are your baseline here. And if you don't understand how your variables actually interact, you are flying totally blind.
Okay, burn these rules of engagement into your brain. Rule number 1, ratios relate quantities. Rule number 2, ditch the colons. Seriously, I do not want to see A colon B on my obstacle course. You write them as fractions, A over B, because you cannot efficiently do algebra with colons. We use fractions for actual problem solving. Rule number 3, substitute your known values. And rule number 4, execute your algebra to solve for the unknown. Do you read me? Excellent. Now let's hand it over to the board mentor for your first tactical breakdown.
Right. Thanks for that, Sergeant. Moving on to Section 2, direct versus inverse. Let's identify your target and see how these variables actually interact in the wild.
It's honestly amazing how simple this dichotomy is once you really look at it. On side A, we've got direct proportions. If I buy more apples, my total cost goes up. They move together. Mathematically, this just means their quotient is a constant. Apples divided by cost always equals the exact same number. But on side B, we have inverse proportions. Think about it. If the area of a rectangle is locked in at 40 and I decide to double the length, I literally have to cut the widths in half to maintain that area of 40. They move in opposite directions. The math here means their product is constant. Length times width always equals 40. Constant quotient or constant product. That's the whole shebang. It really is that basic. But just wait until you see what happens when we start mixing them together.
Oh man, I'll take it from here. I am your math hype man. Section 3, joint proportionality. What actually happens when you face multiple threats at the exact same time? I mean, check out this absolute monster of a question straight from the source text. If 4 gleeps are 3 glops and 2 glops are 5 glips, how many glips are 10 gleeps? Are you sweating yet? We don't even have a direct conversion factor to go from gleeps to glips. The variables are linked through a middleman. How do we survive this multiple threat scenario? Bam! 18.75 glips. The trick here is that you just don't panic. You step through the conversions sequentially. 10 gleeps times 3 glops over 4 gleeps gives you 7.5 glops. Then you multiply that 7.5 glops by 5 glips over 2 glops, and boom, 18.75 glips. You literally just chain the proportions together. But hold on, things are about to get even crazier with a clock problem. Mentor, take the wheel before I completely lose my mind. Okay, let's all take a breath and break down the classic 4 o'clock coincident problem. It's exactly 4 o'clock. How many minutes pass before the hands overlap? Please, stop memorizing useless formulas and just use basic logic. At exactly 4 o'clock, the minute hand is at 0, and the hour hand is at the 20-minute mark. Let's say x is the number of minutes that pass, so the minute hand moves x spaces, but the hour hand is moving too, right? Specifically, a fraction of the distance toward the 5. Since there are 5 minutes between numbers, the hour hand's new position is 20 plus 5 times the fraction x over 60. Set them equal to each other, solve for x, and you get 240 over 11 minutes. No formulas, just pure, basic proportion logic. Drill Sergeant back on deck. Section 4, Tactical Unit Conversion Factors. Out in the field, units of measurement are your enemy. It is time to learn how to completely cancel them out. So the source text drops this hilarious anecdote. The author goes to college, meets a Canadian guy, asks his height, and the guy just says 180 centimeters. The author literally writes, I stared dumbly, then asked, how many feet? He knew 1 inch was 2.54 centimeters and 1 foot was 12 inches, but do you divide? Do you multiply? This is exactly what happens when you don't have a tactical system, people. You end up staring dumbly.
Do not be the person staring dumbly. Just execute these 3 steps. Step 1, write your knowns. 1 inch is 2.54 centimeters. Step 2, set up fractions so the units cancel crosswise. This is the tactical takedown right here. If centimeters are on top in your starting number, you put centimeters on the bottom of your next fraction so they cross out. Step 3, multiply across. You take 180 centimeters, multiply by 1 inch over 2.54 centimeters. The centimeters cancel out. Then multiply by 1 foot over 12 inches. The inches cancel out. You're left with exactly 5.9 feet. Mission accomplished.
Okay, Hype Man here, but this brilliantly illustrates something insanely dangerous. What if you're converting area or volume, like square feet or cubic feet? You can't just multiply by the conversion factor once. If you're converting cubic feet to cubic meters, you have to multiply by the conversion factor 3 times. You have to raise the entire fraction to the third power to cancel those exponents out. If you forget this, your calculations will be absolutely destroyed.
Breathe, Hype Man. Section 5. Surviving real-world percentages. The word percent literally just means per 100. This is the final test, navigating the everyday math of sales, taxes, and loans.
It's kinda sad how many people agonize over word problems when a simple little translation key solves 90% of them. When a math problem says the word of, just write a multiplication sign. When it says is, write an equal sign. It translates confusing English directly into a clean algebra equation. Let me show you how this helps you avoid the most common trap in the book.
Let's see how this builds into the ultimate textbook trap. A $10,000 car decreases in price by 25%, then increases by 25%. What's the new price? The rookies always say, $10,000. Wrong. The decreases and increases absolutely do not cancel each other out because the base value changes. Step 1, decreasing $10,000 by 25% means you're actually paying 75%. So 10,000 times 0.75 equals 7,500. Step 2, now you increase that new price by 25%. So you multiply 7,500 by 1.25. The result? $9,375. Step 3, you literally just lost $625 because you didn't respect the math.
Now let's see how beautifully that translation key works in action. 75 is 20% of what number? The is becomes an equals, the 20% becomes 0.20, the of becomes multiply, and what number becomes x? So 75 equals 0.20 times x. Boom! Divide both sides by 0.20 and x equals 375. It's completely effortless. You're turning words directly into tactical equations.
And finally, let's talk about interest, which honestly is just a percentage increase in disguise. Say you borrow $2,000 at an 8% annual interest rate. After 1 year, you owe the original $2,000 plus 8% of that $2,000. If we just use the distributive law backwards, that means we multiply 2,000 by 1.08. One quick calculation, and there's your total, $2,160. Once you see the patterns, it's all just the exact same simple machinery turning underneath. All right, time for the debrief. You've survived boot camp, but remember, out in the real world, the math compounds. Here's your final test to take with you. If you borrow $4,000 at 5% annual interest, how much are you going to owe after 4 years? Remember, that interest stacks up year after year. I want you to calculate the damage and really ask yourself, will your wallet survive the compounding math? Keep your fractions sharp, cross out those units, and whatever you do, never trust a sequential percentage change. Dismissed.